to talk about the normal distribution quick. And this is just kind of the foundation, basically, of statistics in general. So the normal distribution, like if you had a bunch of bar graphs, or like a histogram, so, you'd have all these bars and maybe something like this, And so the shape of it, if you kind of outlined it, might look like that. So right now, where did my eraser go? Sorry. There it is. Okay. So when you draw these graphs, it would be data. So like with the virus, you'll see a lot if you look, little bars, right? And kind of this growth rate that's concerning, right? Okay. So, we're kind of doing one of those type of deals. So the normal distribution is sometimes known as the bell curve, but it goes up, it goes back down. Okay, and those should be a little flatter. All right, and so some people call it the bell curve. Some people, most statisticians would call it the normal distribution. And inside here is 100% of the area. If you think of that as area, like this has an area of 1 or 100%. And so what happens is your mean or your average is in the middle. Okay, so that's where our mean is at. And then we have 3 standard deviations each way, and it's symmetrical. Okay, so you have 1, 2, 3 standard deviations this way, 1, 2, 3 standard deviations this way, right? And so then we have this 68, 95, 99.7, and pretty much most people that teach stats or, would have that memorized. And what that means is that within 1 standard deviation, either direction, is 68% of the area or the probability. So if I take 68% and divide it by 2, because I have 2 regions, what that means is 34% of the probability or the people or whatever you're looking at falls within 1 standard deviation. So if you're 1 standard deviation above or 1 standard deviation below, you're with, 68% of the population would be there. Okay, and we'll talk about trying to tie it to a real life scenario here. Within 2 standard deviations, so that's within 1 standard deviation, within 2 standard deviations is 95%. And so notice we've already used up 68 of that area. So that leaves, 27 for that, right? And if I go ahead and split that 27 in 2, what that means is this is 13.5% here and 13.5% here, okay? So, again, if you're within 2 standard deviations, plus or minus, 95% of the population is within 2 standard deviations of standard, within that. And so we would not, in statistics, we'd say that's not rare. If you're within 2 standard deviations of the mean, either plus or minus, that's not really rare. When we get beyond that percent, then we start to think things are rare. So when things are beyond 2 standard deviations, we start to consider them rare. All right, so remember the whole circle, or the whole, graph is 100%. So far we have 95. So within 3 standard deviations, plus or minus, is that 99.7. So we've done that. So 99.7, again, we've already used up 95 of the area. So that leaves, 4.7. Divided by 2 is, 2.35? Okay. All right, so that would be there. Okay, so you can see the percents are going down as the tails get tinier and tinier. And then the last one that obviously isn't written is 100% is all of it. So I have 100%. I've used up, 99.7%, so that was 0.3% for each together. And so that's like 0.15%, not even 1% in the very tails. Okay, and so that is extremely rare when we start to get out there. Okay, so this is called the normal distribution, and these percents hold no matter what you're talking about, which is kind of cool. So I'm going to go ahead and erase this. So any chart, any data basically in the whole wide world that's normally distributed are going to be fit on this chart. So let's take IQs for an example. Okay, say the average IQ is 100. and so the average is 100, and say that the standard deviation is 15, okay, and say this is points and points, okay. So the standard deviation is 15, so I can add 15 over and over again, so 115, 130, 145, so then when I add one standard deviations, two standard deviations, 3, and I can subtract it. So 100 minus that is what, 85, minus again is that what, can't do mental math today, 60, and then is that what, 55 I think, okay? All right, so I'm gonna just double check because I don't want to make a dumb mistake on a video, that would be bad. 15, and then minus 15, okay. So all I did there is I added 15 over and over again and subtracted. So, for example, what percent of people have an IQ between 100 and 115? So if you're in this range, like what's the probability that an IQ is between 100 and 115? Well, this chart tells me. I know the probability of that is 35 or 34%. 34% of the population is going to have an IQ between 100 and 115, okay? Half of the people are going to have an IQ, right? 50% are going to have an IQ more than 100, 50% less than that. So, again, there's a group called Mensa, and I can't remember what their cutoff is. You can look it up online, but it's kind of like, okay, what's your probability of having that kind of IQ? Well, say their cutoff, and I think it's higher than 130, but we'll just say it's 130. So what's the probability that someone has an IQ greater than 130? So you look, here's your cutoff of 130. So that's really only 2.5% of people have an IQ that high. So then Mensa would let you in their little club. And again, I don't know what their cutoff is. I think it might be like 138 or 134. So it's even higher than that, I think, but I could be wrong. So basically, once you have this chart and you have your cutoffs, then you can figure out any probability. And the cool thing about this chart is it doesn't change. The bottom numbers change here. So like say I'm doing ACT data, okay? And say that, let's see, the average ACT score is say 24, okay? I think for some subjects like English it might be 18 or something like that, but say that it's 24, and say, so the average is 24 on one of the ACTs, I don't know, math, whatever, and then say the standard deviation is 4, okay? So I know that these numbers are going to hold, 34, 13.5, 13.5, 2.35, 2.35, and 0.15, 0.15. And so I'm just going to add my standard deviation 3 times. So this is going to be what, 28, 32, and 36. And then I'm going to subtract it. So 20, 16, and subtract 4 again is what, 12, okay? So again, if you look at the probability, and I think that might be a little high. I think it might be more like, at least in math, I think it's around 22, but we're just kind of making up data here. But, so for example, if your ACT score was anywhere from, say, 16 to 32, 95% of the people that take the ACT would have that range, okay? If the average was 24 and if the standard deviation was, 4 here. So, again, if you're like, oh, well, you know, why do those people that get a 36 on the ACT, why do they get a free ride? Well, what's the probability that someone gets, you know, ACT, and we'll just say 36 in this case, but usually it's greater than, but we'll just say 36, right? Because you can't get greater than 36. They're probably in the tail there, so there's like, you know, 0.15% of them, or, you know, maybe if my average is a little lower, right, then maybe that might be, you know, like the 35s and above. And then if some of you are like, well, why do we accept people that have an ACT of 18 in some colleges? Well, again, they're within 2 standard deviations of the mean, so, you know, that's 95% of the population is there. So even if you're a little bit below average in a height or in weight or whatever, it's probably not statistically rare. So if we take, like, say, oh, I don't know, let's take snowfall here. Say the average snowfall, so say the average snowfall in a month was typically, say, 4 inches of snowfall, and the standard deviation was, say, 2 inches, okay? So then the average is 4, and then we get 6, 8, 10 this way, subtract 2, 0, this isn't going to make sense. Let me make the standard deviation one. We can't have negative snowfall there, so that's a problem. All right, say this is 1 inch is the, so we have 4, and then 5, 6, 7, and then subtract, so 3, 2, 1, okay? So then again, I can look, like, what's the probability that the snowfall, right, is less than 2 inches? So then I'm over here, right? And so that probability is about 2.5%. And in statistics, we would say that's rare, right? Like for this state, that would be rare to get less than 2 inches. I could say, okay, what's the probability that the state gets anywhere from 2 down 2 to, again, let's say 5, 2 to 5 inches of snow? Well, then I would add up those probabilities. So from 5 to 2, I would add up my, what is that, 68 and my 13.5, 8, 9, 10, 11. Okay, is that 81.5% probability that that's going to happen, which, you know, seems pretty high. So again, once you know the standard normal distribution, those percents never change. Just the data that you're putting on the bottom is going to change, which is kind of cool. We'll talk more about this in class, but again, hopefully this will give you a good foundation so that we can keep moving forward. All right, I'm going to stop the video and we'll go from there.